right, so this question's fun. A ball is thrown into the air by a baby alien planet and system of Alpha Centauri with a velocity of 49 feet per second. Its height after t seconds is given by y equals 49t minus 14t squared. The first part is find the average velocity for the time period beginning when t0 is equal to 2 and lasting for the given time. So here it's saying lasting for 0.01 seconds. This is the same thing as saying find the average velocity on the interval 2.0. And so we know how to do this. This is the change in y over the change in t. So what I'm going to be looking for here is y of 2.01 minus y of 2 over 2.01 minus 2. So what might not be obvious and what's crucial to see here is that this is actually asking for the average rate of change on the interval 2, 2.01. If our interval starts at 2 and lasts for 0.01 seconds, then it goes from 2 to 2.01. And so we actually know the formula for this should be y of 2.01 minus y of 2 over 2.01 minus 2. So this calculation is what should go in here. And the only thing that's missing, of course, is that what is the formula for y? We can do these calculations now. Let's go ahead and go to y equals 49t minus 14t squared. That in there correctly. And let's zoom out a little bit. We can see the nice parabola shape. And I know the calculation I want to do is boxed down here. Y of 2.01 minus y of 2 divided by 2.01 minus 2. And I might need to tell it that this is y of t so that it actually can calculate that. Does it not? What is it not understanding? This won't bother it. There we go. And I can click it and get an exact answer, and that's what I want to do. So this button where you have this fraction highlighted can convert what you have into a fraction. And so by clicking this, I can toggle between whether it's decimal or fraction. And I definitely want the fraction one if I get that. But either way, let's try it both ways, see what we can get. It tells me it's okay. You know what? Instead of trying to use a different tool, why don't I just do what I want, which is 49 times 2.005 minus 14, 2.005 squared minus 49 times 2 minus 14 times 2 squared. And I need parentheses here to make it work out. Divided by 2.005 minus 2. And if I preview my answers, I can look and see, okay, does that look like what I was hoping for? And it does. So I'm going to go ahead and then check the answer, submit the answer, and it liked that. So now I can copy paste, because if I recognize what needs to be changed here, then I can see that this pattern is not too hard as long as I see what numbers are changing. So I submit that, and that's correct. And then I'll do this again with 2 to 2.001, and I just have to be careful again that I'm copying and pasting carefully. Now, when it asks for the instantaneous velocity, remember that we can calculate the instantaneous velocity via a sequence of average velocity calculations. So each of these calculations should give increasingly accurate estimates of the instantaneous velocity. Now the question is, what's the trend here? So if I look at these numbers, it looks to me like I'm honing in on at least negative 7.0. What I want to look for here are what are the numbers that are in common as I do these. So I see negative 7.0 over and over again. So I'm going to go down, I'm just going to type negative 7.0 based on these estimates that I've been doing, and that's absolutely right. There may be other answers that are acceptable because, again, it's asking you for an estimate. But what I want to emphasize here is that when you look at a sequence of calculations, you're getting the ones that they have in common. This is more of a trend than a single calculation. So it was important that we do several calculations to get this idea.